Hey, this is Ryan, and today I want to spend a little bit more time with DynamoDB. And in this tutorial that I'm following, we will look at some of the best practices of how to design your database. So DynamoDB is usually good for high-scale applications, and it's also good for serverless applications, pay-per-use. Before we get into it, we'll just go to part 1, where we load up a Cloud9 environment, a virtual environment. So type in Cloud9, create environment. I'll call this DynamoDB restaurant. Leave all this as default, T2 micro and Linux, and create. And that will probably take a minute or two. All right, all set up. I'm still kind of new to Cloud9, so if you see me do something that looks odd, then that's probably why. First, I'm just going to get rid of this tab. And okay, so here's our terminal. Let's see what's in it. So ls. Okay, nothing. So that means first we want to make sure we are. First, we want to make sure we're in the right directory. That looks good, and if not, you'll just paste that in there. And now we're going to download our files from an S3 buckets. Okay. So we have our scripts, and let's see what's in application. This is our directory that contains code for interacting with your data. Okay. And I think we already have this installed, but I'll execute this one as well. Control L to clear. Okay, moving on. Step 2. Now we're going to actually look at how to model our data with DynamoDB. So the relational databases, which is not what DynamoDB is. DynamoDB is a non-relational, but with a relational, you normalize your entities with atomic units, with each entity being represented in separate tables. But with DynamoDB, we can't join tables, so we can't do that. So the reverse is true. We need to consider how we're going to, well, let's just call this our access patterns. Let's consider our access patterns. And we're going to create an entity relationship diagram, ERD. So in this example, if we have a restaurant review app, we have an entity that would be a restaurant. These are our relationships. And then another entity is reviews, and these are our relationships. So normally you would divide these up into different tables. With DynamoDB we can't, so we're gonna keep these in the same table. So for reviews we have a username, rating, the body, and where it was created, what restaurant. And for restaurants we have the name of the restaurant, the address, cuisine, and phone number. So moving to application access patterns. We have 6 access patterns for this application. Fetch restaurant summary, create restaurant, get restaurant, create review, get review, and remove review. All right, part 3. Plan our data model and load sample data. Okay, so we don't have any joins, and we are limited in the attributes that we can query our data. So we're going to put our multiple entities in a single table, and the entity is, again, a restaurant and the review. Use generic names and values for your primary key. So we don't want to use restaurant name or rating ID because some entities won't have these properties. So we'll use a partition key, PK for partition key, and SK for sort key. That will help with our access patterns. And then we'll use secondary indexes to handle additional access patterns. So let's start with the primary key. with our primary key, we need a partition key. And the second type is a sort key. So we have to consider uniqueness for both our entities. So restaurant has to be unique by its name. And we want to make sure that the user can't leave multiple reviews for the same restaurant. So here's an example. We have our two entities, restaurant and review. This will be our partition key. So REST, so rest number and then user number, and our sort key. So here's an example. You have our restaurants and our users. These are the attributes it could be. So this is the name of the restaurant and the cuisine. And then for the reviews, you have the restaurant again, the username, and the rating that they gave. So the basic primary key pattern has satisfied 5 out of 6 of the access patterns. The last one is handling the fetch restaurant summary. I guess we'll get back to that. So for each item in our database, it looks like we have an average for our review. So for Susan Steaks, you can see that has an average of 6 reviews for 5 stars. And for 1 star, you have 6 as well. Okay, our second strategy, this helps us retrieve the restaurant item and the 5 most recent reviews in a single request. To do this, we'll use a secondary index to reshape our data. This adds another primary key and a sort key. So global, secondary index, primary key, and sort key. Okay. So when a review is created, the application assigns its review ID. That is used with the global secondary index sort key. The review ID is a K sortable unique identifier, so KSUID. This provides some uniqueness. This provides some of the uniqueness guarantees of universally unique identifiers. It also includes a time-based prefix that allows for chronological sorting. So we can use that to look at the most recent reviews, which is what we want. Here's an example if we swapped around our index. So instead of having our user show up, over here is a primary key. We're going to have the restaurant Thai time show up, and then we're going to sort that by the reviews, and then later on you'll have the attributes as the user and the number of reviews. Okay, let's do some hands-on work. So creating the DynamoDB table in the scripts directory that you downloaded, a file called createtable.py. So let's cd into scripts. And create table.py. Let's just scroll through here first. So we're going to import Bado3. I think that's how you pronounce it. It's a Python software development kit. So to create the DynamoDB table, we're going to create our attributes, our schema, our secondary indexes, and our throughput we defined here. Alright, so if we tried running the script to create the table, I tried this the other day, so it's, for some reason it did not import our Bado3 kit. And the way I got around this was I ran a separate command this time. So Python pip install and user Bado3. That command should work. So now if we try running this script one more time, it should create. Okay, so this table created successfully. All right, if you want to verify that, you go to DynamoDB, tables, and here's our table. So let's click into that and just leave it for now. Next, load some sample data into the table. We'll run this command. Items loaded successfully. So going back to the table, refresh. And here is all of our data. So looking at our partition key, here's a list of name of restaurants, for users. In the next module, you'll interact with DynamoDB in your application code. Okay, step 4. Remember, there are 6 access patterns. We'll learn how to write the code to implement 3 of the access patterns. So create a restaurant is one of them. Let's start with that. In the application directory, there's a file called create restaurants. Okay, create. Whoops, sorry, I'm in the wrong one. Okay, application. Okay, create restaurants. So let's use a text editor. I'll just do vim create restaurant. I to insert. Here's our function to create a restaurant with the name, cuisine, and address. This is the exact restaurant we're going to create. It's titled Any Company French. Over here, the way they named it was Bev's Bistro. So for this restaurant, let's rename it to match that. Bev's Bistro. And it has a condition expression. This is used to assert that the item with the same primary key does not already exist. So that condition will be right here. So attribute. So it's just going to allow us to make sure we just have a unique restaurant each time. Otherwise, if we try to recreate the same restaurant name, it won't let us. It'll say could not create restaurant. All right, so press escape, :WQ to save it. We'll try to run the script. Go back into our main directory and copy that and paste. Okay, so it's created restaurant, Bev's Bistro. If we try that one more time, it'll tell us could not create restaurants because that condition worked correctly, so it didn't let us duplicate it. So Bev's Bistro will be in here somewhere. We're not going to bother searching for that for now, though. Okay, next, adding a review to a restaurant. We want to make sure that the user cannot duplicate and add a additional review. It has to be unique. And we need to increment the relevant rating attributes. There's a new Python file. Go back into applications. And vim, what is this? Create review. Here's our rating, 1 through 5. And also we'll have to import KSU ID. We'll get back to that. We have another condition down here, making sure that we can't duplicate our review. And we need to update this to Bev's Bistro again. Make sure it matches that, Bev's Bistro. So escape, :WQ. If we try to run this code, it's going to give us an error because we didn't import KSU ID. So let's just try and see what happens. Yeah, it says we need to import that. So I have another script or command that I found, just like the last one when we imported Botto3. So let's paste that. So pip install user get KSU ID. Okay, successfully installed. So now let's go back and run that script, create review. It says added a review from Hungry Hank to restaurants Bev's Bistro. So that works. All right, the final access pattern we'll cover is the fetch restaurant summary access pattern. So we want to find the 5 most recent reviews. The query operation allows you to read multiple items with the same partition key. With a single partition key, items are ordered according to the sort key value. Here's our partition key. Here are the reviews. And because we're using the KSUID, the reviews are ordered chronologically. Okay, here's our script, fetch restaurant summary.python. Gonna fetch restaurants. Scan index forward equals false. This means it's going to go from the last reviews. So the most recent reviews is what it means. And the restaurants we're looking for, we're going to search the Vineyard. Remember, I tried this the other day, and there's not actually a restaurant called the Vineyard. I'm just going to edit this into something that we actually have in here. Like a restaurant could be any company, fine dining. So let's go into this Python file. That'll be in the applications directory again. So vim fetch restaurant summary. We have to go down to restaurant and we want to edit this. Any company, fine dining. Okay, so we can actually keep that as default, or you can pick any of these restaurants that you see in here. Let's just leave it, I guess we'll just leave it the same. All right, so let's try this command. We're gonna fetch the most recent reviews. And here you go. Here's 5 reviews. So from restaurant, any company, fine dining. These are our users. This is the timestamp. All right, I guess we're actually done with that. So before we clean that up, if we just went back to DynamoDB just for fun, and if you wanted to use the scan feature, let's add a filter. Let's say we just wanted to search, so we have to enter our attribute. That could be, let's just try typing in PK for this attribute. So string equals, or let's do contains, has to contain any value that has any company. Start search. Okay, so we're filtering this attribute with anything that contains any company. That's what it resulted in. So clear that, you click this X, start search, bring up all the values again. So to clear this up, there's a script that has a delete table function. So let's go back here. As in the scripts directory. All right, so let's delete this table by running the script. Table deleted. And now it's deleted. Additionally, delete our Cloud9 environment. Delete. Okay, we're all done with this tutorial. So in the next one, I'm going to continue this and we'll work with Amazon Elasticache.